So hello everyone, and we are going to discuss Codeforces round 916 div 3. So it will be a roughly solutions video from A to F, which I was able to solve, though I was not able to solve F in the contest because it was unrated for me, and I was giving it in a very leisure way. So yeah, so there was a lot of time that I did also look for C, that it has a compilation error, the C, and I just went on and the contest site was lagging a lot. So let's move on to problem by problem. Without much further ado. So yeah, the problem A, we have that there are some problems, and there are exactly 26 problems, and you might be having a string in the input that depicts the problems. Now it's given according to the rule that every problem, which is like A problem takes 1 minute and B problems takes 2 minutes, and going on to Z, which is 26 minutes, which is something similar to the ASCII notations only, and like the numbering, the increasing order. And then you say that the ith letter tells you that which contest problem he is solving at that ith minute, or thinking about. Basically solving means thinking, he might be thinking at that time and not exactly solving it. And then if he had spent enough time to that problem, he must have solved it. So at a particular minute, like in a very real contest, we switch between the problems. I can switch between problems A, then might be opening B and then thinking about B, and I know that after 30 minutes I will be done with A and B both. So similar example has been taken. Like if you see the string here, what you can say is, like if you see the string, like it is A, B, C and C, and then you have this BC again. So yeah, so at first minute he was solving A, and since A takes 1 minute, he solved it. At second minute he started solving C, and then he started solving B at the third minute. So C, he has thought about it for like 1 minute. So C, 1 minute has been gone, and then he's thought about it B for 1 minute. So B is 1 minute gone, so the leftover time for B is now 1 minute, because B usually takes 2 minutes. And then for the leftover time for C is now here, like after this you will be, because C takes 3 minutes, you took 1 here, so now it's left 2. You took 1 here, so it's 2 minus 1, 1 left. Then here 1 was left, he took 1 and 0, and B also became 0 and A also became 0. So he was able to solve all the 3 problems. So basically there are many ways to go about this problem. Either you can go about that you have a string like A, C, B, C, F, or C, B. So you can say, okay, this is A, so A is required time. You can just have an array of required times, like according to 26 letters, and each letter has a required time of their index value, like it's from 0 to 26. So they have 0 to 25, and they have from 1 to 26 they have their time. So you can say A has a right 1, so you minus 1 here, and then no matter how many times A arrives, you have solved A. Okay, because you only want 1 minute for it, and after 1 minute, no matter how many minutes you were thinking about that problem, you must have solved it. But you are just at that point of time, you have opened the problem. Like even after solving one problem, you open the past problems. So yeah, that was dealt with in test case 2. Like he solved the problem here, then he kept opening A for the rest of the 3 minutes. He wasn't able to do anything there. Then F usually takes 6 minutes, so you have solved F. Now 5 minutes are remaining, because F is the 6th letter. And then it's P, also takes some, like I guess it's 16 P. So P takes 16 minutes, and definitely you have not dealt 16 minutes on this problem, so you won't be able to solve F and P, and neither you will be able to solve C. So the answer for this case is 1. So one way is going about here, that you have a predefined required times for all the problems, and as they appear you minus that particular minute or the number of times they appear, and you can see that if that problem reaches 0, like at any point of time, you increase the answer by 1. That is one way. Rest of the way is just count the letters, like count the occurrences of each letter. If their occurrences are greater than their required stipulated time, you have the answer that you will be able to solve. So this is my solution to the A problem. Yeah, so what I do, I created a count 26, then we went on, there's a memset thing, nothing. Now I counted each of the occurrences of each of the problem, and if the required, if the time given by me, which is the equal to the required occurrences, because that occurrences depicts the minutes I would have dealt on that problem. If it is greater than or equal to I plus 1, which is because for 0 you want 1 here, and for A you want 1, then you just do answer less person and end is there. So yeah, you solve this problem. Yeah, now moving on to the B problem. yeah, so I was able to solve this problem. It was pretty easy problem, and the constraint actually don't do justice. You don't have to run an O of n square solution. An O of n solution would more than enough. Like now you have just preparing for the contest, and now what you do is you have our n problems to solve, and to make sure he's prepared, each of this problem has a difficulty of 1, the second problem has a difficulty of 2, and so on until the last problem. So we know that if we are given with a particular n, then we know that 1 2 3 4 there are n problems from 1 to n, and all of them are like their numbers depict their difficulty level. So 2 is greater than 1 in the difficulty, and so on. Now it's written that he gets excited if he feels he's progressing, and the progress means he solves a problem which is difficult than the other problem. And since they are distinct integers from 1 to n, so at any particular time, at ith time, if he solves a problem whose difficulty, which is difficulty of I, is greater than difficulty of I minus 1, then he says that this event is known as excitement. So this particular two-way thing makes an excitement, and the first problem, therefore it's given that the first problem has nothing to do with excitement, because he has just solved this problem, like some problem x, and then he solves problems y. If y is greater than z, here excitement increases 1. Then he solves z, and then if z is greater than y in the difficulty, which is the numerical values, then you have the excitement 1 more. So you want exactly k excitement, I guess, yeah, exactly k times you want your practice session. In the practice session you want to get excited, so basically you want a sub array of length k which is increasing. Yeah, try to reduce the problems in those terms. Yeah, and rest, it should be never increasing. Now it should be completely decreasing. You just want this sub array. So basically you can say that you should have all the numbers decreasing here, then you should have some increasing of k, and then all the numbers decreasing here again. So you just want this one single sub array of elements, basically k plus 1, or basically k elements only, because for excitement 2 you need 3 elements. So yeah, k plus 1 elements you want. Okay, you want a length of array k plus 1 in between where all the numbers are increasing, and you will get excitement k, and rest it should never be increasing because we want exactly something. So what we can do is, if you take the example of 4, or while you can take the example of a greater n, if n is 7 and your excitement level is 4, so I want 4 length. Okay, so what I can do is I can say that if I have all these problems, there are many ways to this answer, and multiple answers exist. Either you can take 4, you want 4. Okay, so take this 4, basically 1 2 3 4, but again you would just take this element which is greater than this, then you will be able to get a 5, because every time you take anything which is like, if you take 1 2 3 4, your excitement is still like what, it's still 3, because here excitement 1, excitement 2, excitement 3, and then you have 7, and then you have 6, and then you have what you have 1 2 3 4 5 6 7, yeah, and then you have like you can just repeat because you want decreasing. So here is a 1 increasing k, and k plus 1, and then here's so k is 4. You took the 5 elements, like just take the 5 elements like this, take the k minus 1 elements, basically exactly k elements, because if you just take this thing and you like k, you want k, and you take k plus 1 elements, like you take till 5, and then when you reverse this, because you don't want more to increase, so every time this one number will be greater than 5 and you will get one more excitement. So just take k elements and reverse the portion. So just take k elements like this, and then just reversing it, because last element will always be greater than your last taken element, and then you can do this. So here the level is good. We can take a second example for a minute, like which is 5 or 6 2, first example only. And for 6 2 you can have like, for 6 2 you can take a 1 2 and 3, and because you wanted 2 elements, you took a 1 and 2, and then you can say 6 5 4 3. The excitement level is 1 event, 2 event, and that is good. What I did was, if we have 1 2 3, I don't know why I did that, because this is much more easier solution. If I have the 7 elements, I took the last n minus k plus 1 elements as a starting point, and then just reversed it all and took the first element as 1. So there are multiple ways. The best way is to take the k elements, starting k elements, and the next n minus k elements, just reverse them, and that is good to go for this problem. If you want to see my solution, it was I don't know why I did this and why this was intuitive for me. If k is 0, definitely you just need to reverse it. You don't need anything. I just try to like deal with the edge case so that I don't get a wrong answer, but I do get it. And then I just printed 1, and then all the elements from that shift of 4 elements, or basically k elements shift is there, because n minus k plus 1, and n, this will give you a length of k elements, and rest of the elements you print like this. So pretty much, like, I don't think it's a good solution. And it's like this: 1 5 6 4 3 2 for the first 4 3 2. Yeah, so it's one and the same thing. It's okay. Yeah, so let's move on to the C problem. A was a pretty, A and B were like, B was pretty much more easy and then A in understanding, and both A and B were pretty easy. Now C is basically a good problem, and I won't say a very good problem, but I did get a wrong answer because there was a compilation error I couldn't notice at this point of time, and I went to solve D and E, started reading it, and then because there was a lot of Q, and then I returned it, and there was some mistake in it, which was a very big mistake because I didn't read the problem correctly, and then I had a wrong answer here. So yeah, so basically they want that you are playing a computer game, and in order to level up this character, he can complete Q quest, and there are n quests in the game. So okay, and if you have not read the problem pretty much says like this, that you have some quest, like, and you can only complete the, or you can take part in the ith quest if you have completed all the quests from I 0 to I minus 1. Okay, then only you can take part in this. And then you have 2 rewards: first time completion reward, and then constellation rewards. Basically, like, you are going to that quest again and again and getting some rewards. That amount is fixed, but if you are going to that quest first time, that reward is different. So this is first time array, and this is rest time array, which is A and B in the problem. Okay, so what you are doing is, if you are you have a, and how you proceed, you first of all, because you have to solve the, or complete the 0th quest, you have nothing in prior, so you first do this quest, get your first time reward in your answer, then you go to this quest. Now you have a choice: either you take the reward from here, like take the reward from here, and because either you can take the reward from here, or you can just again and again play this quest again and again, whichever is maximum, and you proceed till here. Like, after you complete these 2 quests, you can proceed to this quest, and now you can just take the prize from here right now, because you are firstly completing it, not this, because you are not like redundant. You are first completing this third one, and on the second quest you can take the consolation prize again, because you can again do this quest instead of doing the third quest. So that's how you need to proceed and get the maximum, and you have to just participate in k quests. Like, the again participation is also a participation, so exactly k quests you have to participate, and there is an n, there is a k, and you have to find the maximum answer you can obtain from here. So the problem is pretty much clear, I guess. And yeah, so what you can do is, we can take the example of this. You have 6 and 4, and yeah, I guess, okay, yeah. So so let's take the example of this. Let's take this example, like, and it's pretty much 1 4 5 4 5 10, 1 4 5 4 5 10, and it is 1 5 1 2 5 1 1 5 1 2 5 1. So you just first complete the first quest. According to me, you complete the first quest, and you complete the first quest. Okay, then then you get 1 reward, and then you complete, like, you have a choice, like either to this is 5. You have a choice either to take 1 and 4. You definitely take 4 because you don't want to you have 4 quests in order to complete. You have completed the first quest, you take 1, you take 4, and now you have these two choices, 5. And now this is very like thing that you can either take this one or you take this one. I would prefer to take this one because that opens my door for this quest as well. So I will take 4, 5, and now instead of taking this 4 and 1, I will again complete the second quest and take one more 5, and I think that is pretty much it. It's giving me 15 here, and that was the intended solution for this. Yeah, so what you can do is you can just stimulate this thing once and for all, like one, like if you have this A1, A2, A3 till AN, and you have, sorry for the bad handwriting, I don't have any like equipments right now to draw it neatly, and this is like your array. So what you can do is at any particular ith quest, the sum till now is your sum till ith quest, what is your maximum sum you could have obtained from here. And now what you can do is you can either for the rest of the quest, for the rest of the moves list, like k moves, k is your maximum number of quests, and till ith quest you have taken, you are standing on some ith quest like this ith quest, and you have a sum till ith quest. So in rest quest that are left is like left, left quest can be k minus I, that k minus I quest are like it will be k minus, because I is from 1 base indexing, it will be I plus 1, like these quests are remaining. So for these remaining quests you can either choose from 0 to I, you can either choose the maximum 1, because always you will take the maximum 1 which give the maximum constellation price and go and finish that quest, or you can just take the just arrived or opened quest, let us, and like either it can be this leftover into maximum of b of I from 0 to I, maximum of b, or it can be just a of I, currently a of I, and you can just proceed towards more quest. So this way this greedy works, the solution, because at any point of time you can just because if you are taking this maximum, you have this answer, or you have if that maximum answer is not as good as your answer which you are doing, like there's a that maximum answer, you take the maximum answer into consideration, and then again go for this, because every quest has two choices. Either you, after completing that quest, you take the maximum and complete the whole journey of your k quest, or you just keep on moving for the ith quest. So this can be stimulated in the code very easily, like of course, and you need maximum of this b, like you need maximum of from 0 to I, which I written here basically. So first you just, this is a prefix max thing, and you take this prefix max, okay, of all b of i's. Now if you are present, this is very vague, I don't know why I written it. It can be written as this as well. Yeah, it can be written as this, like you have to go to either n quest or k quest, and it will give you the answer, because when you are k is greater than n, you are considering it here anyways. So what you is this, yeah, you have taken this ith quest. Now you have answer, which is running answer, basically is running sum, and then to that sum you just add all the leftover moves, which is, this is basically your leftover moves, k of I plus 1. Yeah, this is it. So this is your leftover moves. You take this leftover moves and multiply by the maximum you have achieved till b of all b's, and then you have an answer, and then you just maximize that answer, or you just go on till having your quest for the next ith quest and take it the first time completion of that. Yeah, that is it. You just have to stimulate this, and after that you get the answer, like you have just answer for every case, and then you take the maximum of all these answers, because that is what is expected. Like you have to print the maximum possible total experience of points you can get if no more than k quest. Yeah, you have to take that quest, and no more than, because no more than means that you definitely should take k quest, and not less than that, because you have to maximize something. So any value would maximize it, you don't want to waste any quest. So moving on to problem D. Problem D basically, yeah. So on the first site only, I thought it was a very niche DP problem. It was something similar to some AdCoder DP problem which I have earlier studied, and though there are many solutions exist, and there's a one mathematical solution as well. Okay, so let's move on. There are holidays and you have end days, and you have to do exactly one of these activities with your friends, like going skiing, watching a movie, play board games, and you have some number of friends available on that particular day for that particular activity. So if you take one day for skiing and one day for watching, you have to choose those days where you can do at most one activity only, or exactly one activity, I would say, not at most actually, yeah, no more than one activity. Basically you have to do that activity. And after that you can just select the activity you want to perform, and then you combine the answer for the friends that are available to you, and you have to maximize this friends value. So basically you can say that in 1 10 1 10 1 1 and 1 1 10. Okay, you have this like 1 10 1, and then you have 10 1 1 10 1 1, and then you have I guess 1 1 10. So basically on the first day you can go for, this is skiing, this is movie, and this is B game, board game. So on the first day just take for movies, because you have a lot of, because at all the days, though it is only the first day you have maximum number of movie friends, so you have 10 for movie friends. Then on the second day you should go for skiing, because for all the days you have maximum for skiing as well, and then you have maximum for board game, and then the answer comes out to be 30. Okay, this is what the intended answer is, which is pretty much a very straightforward problem. But the solutions, either you go for the math solution, which is available in the solution section of standings. You can say there are many math solutions of those 27 combinations of, because there are 3 arrays, you can like combine them, and there are 27 combinations. No, they're not 27. Like you can take what you want to do first. Either you do first this, you do first this, you do first this. So these 3 arrays are there, and you have 3 factorials. So basically you have 6 ways that either you do first this, then do first this, and then when you are doing something like on the ith day, if you on the ith day, if you choose to movie, then for all the I minus 1 day you have to choose what you are doing first, like for that particular, like if you have SK, MOV and PG in this order, like you do the activities in this order, then on the ith day if you are watching the movies, you take that answer, and from 0 to I you take what was the maximum for Sky Friends, and for I plus 1 to N you take for the maximum for this board games friend, and that is it. This is very actually this solution is much more popular and have been repeated quite a few times in div 3 itself, where the combinations worked and you just have to fix something and go on. And next solution is my solution, which is a TP, and this SK MOV BG, first you can do either this, or you can do MOV BG SK or MOV SK BG. So basically that is 6 ways of rearranging the 3 things, 3 factorial, yeah, permutations and combinations. Next is my DP solution, that if I'm standing on a ith day, I have 3 choices. Okay, so yeah, if I'm standing on ith day, I have 3 choices. Either I can go for movies, either I can go for skiing, either I can go for board games. And these 3 choices are there, so I can keep a mask of these 3 choices, because when I'm running in the TP and I'm on the ith day, and I have a mask which says that I've already done this activity, because you only have to do the activity exactly once, which I guess distinct days are there, because you have to do this activity 3 separate days and exactly once with this one activity. So if I have done with this activity, I cannot do that activity on the ith day if I have already done that activity from 0 to I minus 1 on some day, and that is it. Like you just have to go about this. Like on the ith day you have something known as 2 things. Like either you choose on the ith day, you have a mask or a vector of length 3, any string of length 3, anything will work which have these combinations of 0 and 1 of marking and unmarking things. And if mask, or basically a vector, has that this activity has already been marked, you don't take that activity, and rest activity you have choice either to take that activity or to not take that activity, and you go on till last. And at the last, the base case is when you are on the last, you return 0 if all the activities have been done, or you return -1e9 basically, or some minimum value, so that to state that the things you have done, that is you have not chosen the full activities, or basically you have not chosen some activities, and this particular state or this particular motion or simulation of activities is not valid, so you just invalidate it. So you have this, yeah, D. And yeah, so you have this 3 arrays of all 3 activities, and you have an n. This is a DP solution, and there can be much more better DP solution of space. We don't even consider this I just mask, and I think you should look up for that yourself, because that is a much more interesting thing of using bit mask. Anyways, so you take all the 3 arrays as input, and you just memset. Instead of using memset, just use this, because this is a global thing, and 1e5 for all the test cases of 1e4 will run 1e9. Therefore I have gone only till n, and that is it. And you have 8 choices because you have 3, so 3 choices, and for every choice you have either do this or either not do this. So it's 2 to the power 3, and it goes from 0 to 7, which is equal to 2 to the power 3 only, which is equal to the 8 choices you have. Either not choose at all, or either choose all the 3 like all the 3 when you choose. Yeah, so I have just do recurrence of 0, 0, and when I am on a ith state, if my mask has all the 3 activities already done at particular state, I return 0. This is the second base case, I would say. So I would say these are your base case. Yeah, and this is your DP check, basically, like either you have visited this state or not, and this is your transition plus working on states. Yeah, so if you are on the nth state and your built-in pop count of mask, basically, which is these are very basic things. You can do a vector and say that all the 3 positions of that vector have 1 or not, like marked or not, all the 3 activities have been done or not, which I've just told. So if all the 3 activities have been done, you return 0, either you return minus 1e9. And then you have 3 cases, like what activity you have to do on the ith. You can only do that activity if that activity's mask or position is unmarked, so that mask bit is unset. That is it. Yeah, so you have this mask thing, and you just go to is plus 1. Either you choose this, even after you have a choice to choose it, either you choose it and then you set that bit, or if you don't choose it, you just go on to the other state and go on till now. And when for this particular state, what was the answer? It was masks of PQR. This is a very intuitive solution if you are working on recursive DP. Either rest, you can take that mathematical solution, which is more intuitive, I would say, and more familiar, because sometimes our DP seems a very heavy word, but in my opinion, DP solutions would help you in a long way, because if you just tweak the problem around anything of days or rod, that greedy will fail, and DP is like exploring all the possible states. So yeah, that is it. I hope I was able to explain it. Now we are going to E2 and E1. Pretty interesting problem. It took me a lot of time, but I was also exploring F for a long time, and this is quite an easy problem according to me now. So yeah, and the ledger way, I went on to dinner in between the contest, so yeah, these things happen. Let's go on to the E2, or I won't go to E1 because I had no intention of writing a mask DP of 2 to the power 6. Yeah, you heard me right. If you want a brute force solution of this, which is much more difficult to this, it is not a mask solution, I would say, because you are not storing or caching anything, or basically not performing any DP array. You just have to explore all the 2 to the power 6 ways through recursion, and like if he chooses this state or not, like we will get to this. Yeah, so the problem states that you have some marbles of some particular color, like your ith position represents a particular color, like if 1 it is a particular color, and for the particular color you have A1 marbles available for allies, and you have B1 marbles available for Bob. So A of I for any depicts that for the ith color how many marbles allies has, and B of I depicts for the ith color how many marbles Bob has. And now what the game says is, with allies starting first, definitely on their turn a player chooses a color such that both players have at least 1 marble of that color. So basically that section is not non-empty, that number of colors, and he chooses one, like the player who is playing or whose turn is this, it just removes 1 from his stack of marbles, or and the rest add to his score, and the other one he gives score to other one 0, because he removes all the marbles for that particular color for the other person or the other player, and that is it. Now their score increases, they take alternate turns, and you have to find out what is the, because if they play optimally, basically allies going first have to maximize his score, while Void wants to minimize allies' score. That is, you want to like read it correctly. Allies wants to maximize the score, that is the total score, which is the number of marbles allies has and number of marbles Bob has at the end of the game, which is a score difference. So if he wants to maximize the score, basically he wants more and more marbles his side, and Bob wants more and more marbles to his side because he wants to minimize his score, because he's on the negative side. Some maths, if you get it. And we can go to this example. I find this example very nice. I mean, this actually shows that what you should do. Yeah, so yeah, 100, okay, 100, 20, 19, I guess, 2015 one, yeah, 2015 1, 20 and 20, and here we have 10. Okay, okay, let's go. And yeah, so in the first move, Allies has a choice. Okay, Allies has a choice. So in the first move, Allies can choose any of the marble color. This is color 1, this is color 2, this is color 3, this is color 4. Allies can choose any color. So because at any point if Bob chooses 100, Allies will lose, because that score will become more and more biased towards Bob. So Allies first chooses this according to like observation, or basically according to like, let's take this as a one chance. If Allies chooses this, then Allies' score increases by 1, and he makes this as 0. Then if he chooses another move, if he chooses this, then Bob chooses this, so he makes his score 19, because removing 1 and then adding to 1, he makes his score actually 0 actually. Yeah, he's made 0 score. He made 19 score, and this guy makes a score of 0, Allies. Then Allies chooses this and makes his score 19, and he makes his score 0. Then Bob chooses this, he makes his score 9 and makes his score 0. So 19 is a score for Allies, and 9, 19, 0 and 0. So 9, 19 is 28, and this comes out to be -9. This is the most optimal answer or way of dealing with things, I guess. Yeah, so how to go about this? So you can say that on the ith, if anything happens on the ith color, on the ith color, A of I marbles are present and B of I marbles are present. If Allies makes the move on this ith color, then to the score he adds A of I -1 and 0 to Bob, and if Bob makes the move, he subtracts from the score, basically B of I -1 he adds to his score, but the total score he subtracts, because B के score is -4 and 0. So what you can see is that for a particular sum you have already obtained for all the colors, like rest of the colors, or from any color, and now if you are coming to this, then your sum either goes from your score either goes to this state, or it goes to basically this state, if you are able to get this. Yeah, so it either goes to this state, like these number of marbles have to be subtracted, or this number of marbles have to be added. It either goes to this state or either goes to this state. And now you can say that if Allies makes this move, then your score increases by A of I and your score -1, and if Bob makes the move, your score decreases by B of I -1. So you can say that the overall score is actually affected by the cumulative sum of them. Yeah, because for a particular I color, what has been added to the score, A of I was added, either A of I was added or either B of I was removed. So B of I, you can say B of I was added to Bob's score. So it's a very pretty difficult, greedy to prove why this works actually, But if you see it correctly, that he will be choosing allies for his increasing the score, will be choosing such that the contribution is made less, like the score reduces less. So all the bigger BIs, like you can say that if there are a lot of like if you just trade on Bob's move, like you have Bob's move from Bob 1, Bob 2, for all the n colors you have Bob's move, Bob moves, and here. So for any particular color, this is all the score which he minuses. B of 1 minus 1, B of 2 minus 1, B of n minus. For any particular color, if Li chooses to make this color, instead of this it becomes 0, and you have A of I minus 1 to be added. Okay, so you can say that the cumulative sum of it, which is the sum, if I sort it on the basis of that, so that sum would first of all, what it will do, if I just sum it, A of I plus B of I, and Allies choose this color. If Allies chooses color, it will be optimal for him, because he would have reduced a large, because A of I and B of I, if this sum is larger than, if for some A of I and B of I, if this sum is larger than some A of j plus B of j, then choose this is beneficial, because for Allies, because either just for this A of I and B of I, either A of I, this sum was greater because A of I was greater than A of j, or B of I was greater than B of j. This is the only way that this sum was greater. So if A of I was greater than AJ, then you have added a good score, an optimal score to the Allies, because yeah, if B of I was greater than B of j, then you have reduced a good score basically from Allies. Like you have saved your score from a larger chunk to be reduced. Like B of j is less than B of I, and if you remove B of j, your score is reduced less. So that is what I have tried to say, that like through this you can say that why you have to choose the ith color before the jth color. And again, you have to just stimulate this game in alternate terms. So you should just keep a sum A of I plus B of I for every ith and their index, and see what you can do. Like I would say yeah, so here is my solution. You just make a vector of pair of AB combined, and then you have AB of I as A of I plus B of I, which is very intuitive, which I have told that A of I plus B of I, if it is greater than A of j plus B of j, and then I should be chosen before j. Why? Just now I have explained this, like because in both ways, through A through B, you are actually optimizing your score. Okay, so you just sort all this in reverse order. I don't know why I have reversed it. You can just did iterator, or just greater iterator, or just a greater comparator, and then you have the index, because which particular color you have to choose. This is nothing but color, and then you have a turn, like 0 represents Allies turn, and 1 represents Bob turn. So when you are at Allies turn, you have to increase your score by -1. Either you can decrease your score by index -1, and then you just alternate these scores, and you have the maximum answer. So pretty much intuitive in this sense, and it's not a very hard problem, I would say, after you see this observation that the scores, like you have not to stimulate the game, or basically how they will choose it, or what they will choose it. So even instead of asking these questions, just ask what happens when they choose this color, like how that particular ith color state is affecting the overall score, and you will start connecting the dots. Okay, he's actually reducing this A of I, okay, he's actually reducing B of I, he's actually adding this A of I, and that's all you can do. Like I hope I was able to explain, and if you are not comfortable with this greedy solution and want more proofs that why we are doing it, you can just comment down, and I will definitely help through some proofs if I am able to like give more proofs to this, because it was a very nice problem according to me. And yeah, so don't go for this A part. I've seen some solutions in the standings and they were like brutal when their brood were brutal. Okay, moving on to F. Pretty much easier problem, I would say, because we just have to see what is happening and what can be taken into consideration. So I would definitely open graph editor, I would say. Yeah, what's happening? Yeah, so what is there that you have this corporation where every employee has another employee as their superior, or basically ancestor or more ancestors. Either there is a particular one ancestor, direct ancestor, or there are more ancestors in the line. So you can, and the rule says that you have to create teams, and no two persons can create teams if one of them is superior to another in any way. Like either it should be a direct superior or some indirect superior, that is ancestor wala thing. And you have to tell that if you create teams of two people again and again, what is the maximum number of possible teams you can create. So you can see that just take this example for, because the first example tells you that how to choose teams basically. Yeah, I will have to draw for you, I guess. Yeah, so it says 1 to 1, 1 to 1. So 2 का parent 1, हाँ 1 to 1, 3 का parent 2, and 4 का parent भी 1. Yeah, so yeah, this is a graph, and you have to imagine the superiority and parent thing, because whenever you have this P of I, which is your, for which particular is superior, which employee is superior to particular employee, you should be able to get this parent thing, and through parent thing you should be able to get this tree thing. So once you have this tree, you can see that if you want to create teams in here, like 1 2 4 3 1 2 4, I guess it was not 4 here. Yeah, it was 2 here, it was 3 here, and it was 4 here. If you want to create teams, 2 and 3 cannot create team, 1 and 4 cannot create team. Even one, the utmost superior, which is given into the problem, that there is one utmost superior who is no one who is a superior of the other. No employee can, it is given somewhere that 1 is the utmost superior. Yeah, head of the company, superior of every employee, that is 1. So if 1 is the utmost superior, so you cannot create team with anyone with 1. Yeah, because every time it will come out to be a superior of anyone or else. So 1 and 4 cannot be there, 1 and 2 cannot be there. Like, I am checking all the pairs right now for you. 3 and 4, yeah, they can create 1 2 3 4. 6 pairs were there, we have already encountered 4 pairs. The rest is 2 and 4 is 1 pair, 2 and 4 is 1 pair. This can also be a team, but exactly you can be part of one team. So या तो ये वाली team बनेगी, either this team will form or either this team will form. 3 and 4 to form 1 2 3 4 5, and 1 and 3 is another option, which is waste. So that either you can create this team or this team. So for the answer for this test case is 1. You can create maximum of 1 team only. Yeah, like this. Now we will take this example 1 2 1 1 3 3, or basically you can say this example as well, or this example I would say 1 2 1 1 3 3. 1 2 1 1 3 3. Okay, now how many teams can be formed here? Like you can see that 6 and 7, instead of going to any other thing, they are at the same level, can form the team. Then 3 being alone cannot form the team, and then 2 being here, he cannot form team with 2, but he can form team with 4. Yeah, and similarly 5 and 2 can be form teams, because 2 के साथ ये नहीं बना सकता था, तो वो इधर जाएगा, and 5 and 2 are the same level, so maximum 3 teams can be created. And this is how you proceed. The way I have stimulated things, you can see how I proceeded with the things. So this is the greedy that actually works. Like, first of all, we have to find out the most obvious thing. What is the most obvious thing? That instead of jumping over the levels, if I have some players at a same level, like this, if this is level 1, if this is level 2, and this is level 3, if I have some players that these can always combine their teams, or always make teams with each other, because they are no more superior to each other, they are just valid. And these three can form teams with these three as well, because they are not superior to them. They are not direct or indirect superior to them. They are just branches. Maybe they are superior in the level, but they are not their superior, because they are colleagues of their superior, and they are not directly or indirectly superior. Indirect superior line goes like this. So they are not superior. So they can form teams with it. But the most obvious thing is the people present at the same level. So that is what we will do for proceeding a solution to this. That is we will proceed step by step. First of all, we will create a graph, or eventually it will become tree, and then what you will do is we will calculate the number of people at a particular level. That I have actually calculated who are at particular level, but you will calculate how many are at particular level, because it's one and the same thing. So at a particular level, through a simple DFS, you can find out how many players or how many employees are there at a particular level, which is pretty much easy of running the DFS through depth. And at a particular depth, you can say how many players are there. After this, let's go on to a vast number of cases and determine that how our answer is becoming possible, or how our answer is like going on. So what you can do is you can just take this example. I would say, like this, take this example. This person cannot make group with this person, but at this level he can make group with this person, and these two eventually can make group with each other. So what I would say is, at any particular level, the number of players can be either odd or even. If they are even, then you don't have to worry about. You can just say that okay, they will eventually form team within themselves, and I will have a number that is choosing number of players from that number of employees at that level. So that is pretty much easy. That is easy, because if it's even at a particular level, if the employees are even, it is just employee divided by 2, which will contribute to the number of teams eventually. And if it either it is odd or either it is even. So if it is even, then it's pretty much easy. But if it is odd, then you can see that that extra player will contribute to an extra at above levels, and he has to be now accommodated or paired or make team with any other player who does not belong to his ancestor. So what we can proceed through this is, what we can make this like, we have this. So at this particular level, this is level, these are the levels. Okay, so at this particular level, this is one level, this is one level, and this is one level. So at this particular level, I will say that these two combine through each other, we will have one team. These two combine and we will have one team, and then we can just make this player go here as an extra. So at this particular level, I have an extra from coming from down level, one extra one player. You have extra one player, and then you from here, like also you have even here. So you will combine both of them. You will combine, like, imagine a case like this. You have come to a level, and you have something like this. So you have something a state like this. Okay, when you have something a state like this, you have come to a level where you have something a state like this. You will say that the number of teams I can form is 3 by 2, 1, because now including the extras, I have at this level 3 players, which is fine, because yes, you can combine these two and make one team, and then this one will be left extra, and you will just send this extra above, because now you are dealing with this level. But here your observation fails, and here which might go wrong, like there's a lot of cases of wrong answers when you are dealing with odd even. What I'm saying is, just imagine if the case was like this. First of all, imagine the case like this, because you are not keeping a track of extras kiske hain, like whose extras are there, whose branch extras are there. You are not keeping a like track of that thing. So if this was not there, and you just had this state, so you will say that at this level I have 1, from extras I have 1, this make 2, and 2 by 2 makes me a 1 team, which is wrong, because you have that this and this and this belong to the same ancestor superior or superior belonging, and you cannot create a team through this, and therefore you will get wrong answer every time. So what I'm trying to say is here, like, you have to take a lot of casework into considerations. Like, let's begin and do this. So you have one node at a particular level. Say you have 3 nodes, okay, and you have this extra, like, because this was something which was becoming that something like this, and more above, okay. So this was a state. So यहाँ पे extra, like this is single node, it won't be emerging with anyone because it has this node, and I told you odd even only एक ही extra आएगा हर level पे. तो हर level पे एक extra आया, this extra one, it goes to here. Now you have one extra and one node here. You will say that combine them. You cannot, because this is an ancestor or superior thing, and this 1 plus 1 is not 2. You will not say 2, you will just keep this as extra. You will count this as extra as well, like you now have 2 extras, and now this will become like this. Like what I can say is these 2 will combine and this will become a bigger node, and say that there are 2 extras here. Yeah, like this extra is like not coming or basically hanging from here. And now at this particular point of time, you can say that these 2 can easily combine with them, and they can get rid of, which is our aim. You should be able to merge the extras to the nodes which are not superior to them, or to the nodes through which they can form teams, as early as possible, because more you keep on doing it, the more you will turn the extras of a single line, like this single line extras will actually give you more extras and not able to be merged to themselves, and therefore the answer will be less. So what you can do is here, like once you create this 2 extras and give this 2 extras to him, you check that always leave this, because extra अगर आया है एक level पे, so there must be that if the extra has come to a particular level, there must be one node through which it could have come, only one node through which it could, because you can say that even though extra comes, because at a particular level, if the extra has come, then there will be exactly one node through which that extra would have come, because if that was not the case, if it would have come from 2 nodes like this, so they would have already been merged down there, no extra would have come. Or you can say that if this was the case, so you can see that odd even, if it was odd down there, वो किसी एक particular को belong करेगा, and that it will belong to a particular node. If it was even down there, or odd even like 3, so they would have merged themselves and formed one team earlier, and above at the next level or at the top level, they would have just sent one extra again. So this was the main core combination or main core observation, that extras first of all can come only one at a particular level, like it can only increase by 1, and next, like at a particular level, the extra can either be 1 or can be increased by at most 1. Next thing, that extra would have been like if the extra has been reached a particular level, it would have been converted from a particular one branch only or particularly, or basically you can say exactly एक ही branch, like exactly one branch will be responsible of bringing those extras to a particular level. So just remove this. You can easily say that these extras cannot combine with this, whereas they can combine with any x node that are present here. So that brings to you that at a particular level, if we are at a particular level, say ith level, at a particular ith level, we have extras and we have nodes, that the count of nodes which are there. So I can say that c minus 1, because exactly 1 से तो वो आ ही रहे होंगे, like exactly 1 will be responsible for that, bringing the extras to that particular level, odd even wala case. And then you have extras here. These c minus 1 and extras can combine themselves. So what is minimum between these two will be your merge factor. So minimum of c minus 1 and extra will be creating teams. like this. Like you can say that you have this. So at this particular level, you will be bringing 4 nodes as your I would say 4 nodes as extra, and you have C minus 1 as 2. So your C minus 1 is 2 because 2 nodes are present. Apart from this, which brings that extra, you cannot merge them with them. Not a particular node can be merged, yes. And you have to clear the extras at this level, because you don't have to because when a single line ज़्यादा चलेगी, the single line will keep on moving it, and you won't be able to merge these with the single ones. Yeah, you get my point. Because I'm saying that if you merge, like just see this, if you merge these two, okay, it won't harm you, no doubt, it won't harm you. But if you merge these two, just think logically, if you merge these two, then for all these level, if you merge these two, then for all these levels you have availability of one more, and that is it. So it's one and the same thing, you can say it's one and the same thing. But for surety, you cannot do this because there are many edge cases of like this is an edge case. Like you will say, okay, the count is 2. So implementation is very important here. So if you think it like this way, implementation will become a cakewalk. Like at a particular level, only one branch will be responsible, only and only exactly one branch will be responsible for bringing the extras to that level. Just remove that because you don't want to merge that. Then see what can be merged. These 3 or basically 4 extras can be merged with these 2 nodes. So 2 comma 4 ka minimum, how many can be made? Only 2. So these 2 teams can be made. Like make this, like make this and make this. So 2 teams can be made. Remove this, and just see that if there was one more present, like you can do this, like if there was one more present and there was 4 extras, but now the okay, this is a second case, I would say. Yeah, then merge this, 2 teams have been created. Then remove this, then this one node and these 3 node will again go to next level. Four extras, 2 combine, 2 left, and 1 is this left, and these 2 get merged with these 2. So this is the case. And now you have also one node here, basically, you can say. So at this level, what you are doing is you don't have this at this level. Yeah, at this level, what you are doing at this particular level, you have 2 extras from here and this one, and this all combined to 3 extras here. Now the other case can be you have 4 nodes and only 2 extras here. You have 2 extras here, so these 2 extras will get merged with this. The rest of the nodes are this and this. You again merge them here at this particular level because they can easily be merged. And you will say that the number of nodes at this particular level are not odd, but even merge them themselves. But if you merge them themselves, you will keep keeping the extras. That's the point of simulation. But here, if you just combine these 2 extras with 2 middle nodes, you have 2 more nodes here. You have 2 more nodes. Basically, see in this way, like you have to increase the number of teams. Okay, see in this way, like you have 2 extras here, okay, and you have even number of nodes at that particular level. You will say that, okay, first of all, you said that this is a particular level, just combine these 4. If you combine this 4, you will create 2 teams. Okay, and now these 2 extra will go to another level because यहाँ पे use नहीं हुए. If they are not used here, they must have been, like they have to be used at a particular top level. So you will send that extra to more upper level. Like you have to deal with that extra at a upper level. Okay, so you have to add, particularly at this level, your revenue generation, or because your answer generation increased by delta of 2. But if you just have performed this in a different way, like take this 2 and merge them with this, and then take these 2 as well, and even if it's one more present here, just take these 2. So your answer has increased by 3. You have able to make 3 teams if you are doing it right. You are doing the right thing. So basically, जिसके node, the node that brings the extra, that is exactly 1. So remove that one node from all the nodes that are present at this level, and then take it with extras, take the minimum of this, make that number of teams, remove the minimum from this number and this number. Now the leftover extras are there. Either extras would have been left, because if either c minus 1 would have been greater than extras, or extras might have been greater than c minus. If extras are left, just send that extra above level. If c minus 1 is left, again combine them. Like after combination of this thing, these particular 3 nodes were left, so just do this. C divided by 2, 3 nodes, so it will be 1, and since c is odd, one team will be left. They will, because if there are three people, you can just make one pair, so one more team, and just one people is left. That people will eventually go to that extra thing. Yes. And this is only possible if c minus 1 would not have been left. So basically this is much more intuitive than you think, because like you can say if c minus 1 was greater than extra, okay, if c minus 1 was greater than extra, then extra would have been exhausted, and if c minus 1 would have been left, they would have contributed to a new extra, जो कि एक नए ब्रांच से जाएगा, and exactly again एक ही ब्रांच से जाएगा जो मैंने बोला था. So you are good to go. If extra was greater than c minus 1, then c minus 1 was exhausted to making teams with extra, and the leftover extras are actually coming from that one particular branch. They will again go to that branch, or so. You just prove my point. So that is it. That is how you create teams. So let's walk over the code. You can just say that, not even this, you can just say that you can just keep a count of levels. You don't even have to keep this, I would say. Yeah. So if level at a particular level your I is 0, you should just continue, because you don't, and you start from the bottom and go to upper, and bottom at most what can be the worst case bottom level. If you don't know what is the maximum depth you can go, is n, because when all the nodes are just combined in a single chain, it can go up to nth depth. Okay, so let's see. Yeah, it's passing all the test cases. Now there is some way to, like, the difference came out to be 0. So yeah, so what I have done is, you go to that level, and that is continue. Then you have the number of nodes of that level, and then you have what you have to remove, or basically what you have to merge. So you have to merge minimums of extras and c minus 1. How you are creating extras is because at that particular level, if they are odd, you would have one left from which will not be able to pair at that level, and that will contribute to extra, and that is it, I guess. Yeah. So answer will be that merged number of teams. Now you will remove this merged number of nodes from both the extras and your c. If c was greater, basically if c is still left, those will combine and give you a combination to answer. And talking to the extras, if extras were left, then if c was left, basically extras, तो वो तो ऊपर चलेंगे, that it will go to -1, that is a more lesser level, because this is nothing but iteration over all the levels, level n से लेकर level 0 तक. So these extras would plus it. If c और ज़्यादा बच गया होगा, basically 3 बच गए, 2 लग गए, तो एक जो बच गया वो अब एक्स्ट्रा में कंट्रीब्यूट करेगा. एंड c क्योंकि बड़ा था, तो अभी के जो एक्स्ट्रास होंगे पूरे एग्जॉस्ट हो गए होंगे, तुम ये भी कह सकते हो. सो इट्स वन एंड द सेम थिंग. या, एंड जस्ट यू कीप ऑन डूइंग दिस, and then you just keep on increasing the answer, and you get the answer as this. Your test case passes, and this test case also passes it. So yeah, it's accepted solution. Yeah, it's a pretty much straightforward problem. Just find the number of nodes at a particular depth, and then just stimulate this thing which I have taught. That is it. That is how you tackle and see how greedy works, and why this greedy works. It's very obvious. I have shown you 3 to 4 cases. Just remember those cases, that if we do the branching the wrong way, we will have more extras which could not be combined, and we will have less answer. That's why. So I hope you like this solutions video and learn from it, and I hope meet you at the next contest. And if you have any doubts, like, you can comment down, and I will happy to help. So yeah, tata, bye bye.